Temporary lighting installations at construction sites, carnivals, and fairs are governed by Article 305 of the National Electrical Code. This article provides specific requirements to ensure safety in these dynamic and often hazardous environments. Article 305 addresses issues such as acceptable wiring methods, overcurrent protection, grounding, and the physical protection of lamps and fixtures. The purpose is to minimize electrical shock hazards and prevent fires. It's crucial to carefully review Article 305 to comply with the NEC when setting up temporary lighting for these types of events. Permanent lighting installations in buildings fall under the purview of Article 410 of the NEC. This article is extensive and covers a wide range of requirements for luminaires, lamp holders, lamps, and related equipment. Article 410 addresses topics such as the installation of recessed lighting fixtures, the support and mounting of luminaires, wiring methods within the fixture, and grounding requirements. The goal is to ensure the safe and reliable operation of permanent lighting systems within buildings. Compliance with Article 410 is essential for preventing electrical hazards and ensuring long-term performance. Outdoor lighting installations are addressed in Article 410 of the NEC, though other articles also apply. Article 410 provides guidelines for the installation of lighting fixtures in outdoor locations, taking into account factors such as weather exposure, physical protection, and the need for appropriate wiring methods. It covers issues such as the use of weatherproof enclosures, the support and mounting of fixtures, and the proper grounding of metal parts. The NEC also addresses the requirements for underground wiring, for example in Article 314, which may be applicable to outdoor lighting installations. In addition, Article 250 covers grounding and bonding requirements to minimize electrical shock hazards in outdoor environments. Meeting the requirements of Article 410 and other relevant NEC articles is critical for ensuring the safety and longevity of outdoor lighting systems. Landscape lighting installations are addressed primarily in Article 411 of the NEC, though other articles may also apply depending on the specifics of the installation. Article 411 focuses on low-voltage lighting systems that are commonly used in landscape applications. It addresses the requirements for transformers, wiring methods, and the protection of low-voltage circuits. Landscape lighting often involves direct burial of wiring, so understanding the NEC requirements for underground wiring is essential. This would be in Article 300. The NEC also addresses the need for ground fault circuit interrupter, or GFCI, protection in certain outdoor locations. Article 210.8 to further minimize the risk of electric shock hazards. Complying with Article 411 and other applicable NEC requirements is necessary for ensuring the safe and reliable operation of landscape lighting systems. Low-voltage lighting installations are specifically covered by Article 411 of the NEC. This article addresses the requirements for low-voltage lighting systems that operate at 30 volts or less. Low-voltage lighting is commonly used in applications such as landscape lighting, accent lighting, and under-cabinet lighting. Article 411 covers topics such as the type of transformers that can be used, the wiring methods that are permitted, and the overcurrent protection requirements for low-voltage circuits. It also addresses the need for proper grounding and bonding to minimize electrical shock hazards. Adhering to the requirements of Article 411 is essential for ensuring the safe and reliable operation of low-voltage lighting systems. The NEC is a comprehensive document, and it is imperative to consult the latest edition for the most up-to-date requirements. In addition to the articles mentioned above, there are other NEC articles that may be relevant to lighting installations, depending on the specific application and location. These may include articles addressing wiring methods, overcurrent protection, grounding, and equipment listing and labeling. Consulting with a qualified electrical contractor or engineer is always recommended to ensure full compliance with the NEC and to address any specific questions or concerns. When installing any electrical wiring, it must be done to code. One must ensure the correct wire size is selected based on the ampacity of the circuit. Ampacity is the current carrying capacity of a conductor and is influenced by factors such as conductor material, insulation type, and ambient temperature. The NEC provides tables, such as Table 310.15b16, that list the allowable ampacities for various types of conductors under different conditions. Selecting the correct wire size is critical to prevent overheating and potential fire hazards. Overcurrent protection devices, such as circuit breakers and fuses, are essential for protecting electrical circuits from overloads and short circuits. These devices are designed to interrupt the flow of current when it exceeds a predetermined level, preventing damage to the wiring and equipment. The NEC requires that overcurrent protection devices be properly sized and installed in accordance with Article 240. Selecting the appropriate overcurrent protection device is crucial for ensuring the safety and reliability of electrical systems. Grounding and bonding are fundamental safety measures that help to minimize the risk of electrical shock hazards. Grounding provides a path for fault current to flow back to the source, allowing the overcurrent protection device to trip and to energize the circuit. Bonding ensures that all metal parts of an electrical system are electrically connected, creating a low impedance path for fault current. The NEC provides detailed requirements for grounding and bonding in Article 250. Properly grounding and bonding electrical systems is essential for protecting people and property from electrical hazards. Wiring methods refer to the types of cables and conductors that are permitted for use in electrical installations. The NEC specifies a variety of wiring methods, each with its own set of requirements and limitations. Common wiring methods include non-metallic sheath cable, or NM cable, electrical metallic tubing, or IMT, and rigid metal conduit, or RMC. The selection of the appropriate wiring method depends on factors such as the environment, the voltage level, and the type of occupancy. The NEC provides detailed information on wiring methods in Chapter 3. Ensuring the correct wiring method is used for the application is critical for electrical safety. Electrical enclosures are used to protect electrical components and wiring from physical damage and environmental factors. The NEC specifies different types of enclosures for different applications based on the level of protection they provide. Enclosures are rated based on their ability to protect against dust, water, and other environmental hazards. National Electrical Manufacturers Association, or NEMA, ratings are commonly used to classify enclosures. Selecting the appropriate enclosure for the environment is important for ensuring the long-term reliability of electrical systems. Electrical boxes are used to terminate and splice electrical conductors. The NEC specifies different types of electrical boxes for different applications based on their size, shape, and material. Electrical boxes must be properly sized to accommodate the number and size of conductors they contain. The NEC also specifies requirements for the support and mounting of electrical boxes. Selecting and installing the appropriate electrical box is important for ensuring the safety and reliability of electrical connections. Electrical panels, also known as load centers or distribution panels, are used to distribute electrical power to various circuits within a building. Electrical panels contain circuit breakers or fuses that protect the circuits from overloads and short circuits. The NEC specifies requirements for the installation and wiring of electrical panels. Electrical panels must be properly sized to accommodate the expected load, and they must be installed in a location that is readily accessible. Ground fault circuit interrupters, or GFCIs, are life-saving devices that protect people from electrical shock hazards. GFCIs are designed to detect small amounts of current leakage to ground and to quickly interrupt the flow of current. The NEC requires GFCI protection in certain locations such as bathrooms, kitchens, and outdoor areas where electrical equipment may come into contact with water. Arc fault circuit interrupters, or SIs, are devices that protect against fires caused by arcing faults. Arcing faults are dangerous electrical conditions that can occur when damaged or deteriorated wiring creates a path for current to flow through the air. SIs are designed to detect arcing faults and to quickly interrupt the flow of current, preventing fires. The NEC requires off-site protection in certain locations, such as bedrooms and living rooms. Surge protection devices, or SPDs, are devices that protect electrical equipment from voltage surges or spikes. Voltage surges can be caused by lightning strikes, power grid switching, or other electrical disturbances. SPD are designed to divert the surge current to ground, protecting sensitive electronic equipment from damage. The NEC recommends the use of SPD in certain applications. Electrical equipment listing and labeling is a critical aspect of electrical safety. The NEC requires that electrical equipment be listed and labeled by a recognized testing laboratory such as Underwriters Laboratories or UL. Listing and labeling indicates that the equipment has been tested and found to comply with applicable safety standards. Using listed and labeled equipment is important for ensuring the safety and reliability of electrical systems. When working with electricity, it is important to follow safe work practices to prevent electrical shock and other hazards. These practices include de-energizing circuits before working on them, using insulated tools, wearing personal protective equipment, or PPE such as gloves and safety glasses, and following lockout/tagout procedures to prevent accidental energization of equipment. Always working safely is essential for preventing electrical injuries. Electrical permits are required for many types of electrical work. Electrical permits help to ensure that electrical work is performed in accordance with the NEC and other applicable regulations. Obtaining an electrical permit typically involves submitting plans and specifications to the local electrical inspector, who will review the plans to ensure compliance. After the work is completed, the electrical inspector will inspect the installation to ensure that it meets the requirements of the NEC. Electrical inspections are conducted to verify that electrical work has been performed in accordance with the NEC and other applicable regulations. Electrical inspectors are typically employed by local governments or municipalities. They are responsible for reviewing electrical plans, inspecting electrical installations, and issuing permits. Electrical inspections help to ensure the safety and reliability of electrical systems. The NEC is updated on a 3-year cycle. It is important to use the latest edition of the NEC to ensure compliance with the most current requirements. The NEC is available for purchase from the National Fire Protection Association, or NFPA, and other sources. Staying up to date with the NEC is essential for electrical professionals. Understanding and applying the NEC requires a thorough understanding of electrical theory and principles. Electrical theory provides the foundation for understanding how electrical circuits work, how to calculate voltage, current, and resistance, and how to troubleshoot electrical problems. Some key electrical concepts include Ohm's law, which relates voltage, current, and resistance, Kirchhoff's laws, which describe the behavior of current and voltage in electrical circuits, and the principles of alternating current, or AC, and direct current, or DC. Studying electrical theory is essential for becoming a competent electrical professional. Continuing education is essential for electrical professionals to stay up to date with the latest changes in the NEC, new technologies, and best practices. Continuing education courses are offered by various organizations such as trade schools, community colleges, and professional associations. Many states and municipalities require electrical professionals to complete continuing education courses to maintain their licenses. Engaging in continuing education is a valuable investment in one's career. Electrical safety training is essential for anyone who works with electricity. Electrical safety training covers topics such as electrical hazards, safe work practices, personal protective equipment, and lockout/tagout procedures. Electrical safety training is often required by employers and regulatory agencies. Completing electrical safety training can help to prevent electrical injuries and fatalities. The NEC contains numerous tables and examples that provide guidance on how to apply the code in specific situations. These tables and examples can be valuable resources for electrical professionals who are seeking to understand the code and to ensure compliance. It is important to carefully review these tables and examples to gain a thorough understanding of the NEC. There are many resources available to help electrical professionals understand and apply the NEC. These resources include textbooks, study guides, online courses, and seminars. Additionally, the NFBA offers a variety of resources, such as the NEC Handbook and the NEC Code Finder. Taking advantage of these resources can help electrical professionals to improve their knowledge and skills. When planning an electrical installation, it is important to consider the load calculations to determine the size of the service, feeders, and branch circuits. Load calculations involve estimating the amount of electrical power that will be consumed by the various loads in the building, such as lighting, appliances, and equipment. The NEC provides detailed guidance on how to perform load calculations in Article 220. Performing accurate load calculations is essential for ensuring that the electrical system is properly sized and that it can safely handle the expected load. Voltage drop is the reduction in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction, reduce the brightness of lighting, and increase energy consumption. The NEC recommends limiting voltage drop to a maximum of 3% for branch circuits and 5% for feeders. Voltage drop can be calculated using Ohm's law and by considering the length and size of the conductor. It is important to consider voltage drop when selecting conductors to ensure that the equipment receives the proper voltage. Short circuit current is the high current that flows during a short circuit condition. Short circuit current can damage equipment and cause fires if not properly controlled. The NEC requires that electrical equipment be protected against short circuit current by overcurrent protection devices such as circuit breakers and fuses. The interrupting rating of the overcurrent protection device must be sufficient to interrupt the maximum available short circuit current at the point of installation. Ground fault protection is a type of protection that is designed to protect equipment from damage caused by ground faults. Ground faults occur when current flows from a conductor to ground, such as when a wire comes into contact with a metal enclosure. Ground fault protection devices are designed to detect ground faults and to quickly interrupt the flow of current, preventing damage to the equipment. The NEC requires ground fault protection in certain applications, such as for large motors and for services supplying dwelling units. Harmonics are distortions in the sinusoidal waveform of alternating current. Harmonics can be caused by nonlinear loads, such as electronic equipment and variable frequency drives. Harmonics can cause a variety of problems, such as overheating of transformers and conductors, malfunction of sensitive electronic equipment, and increased energy consumption. The NEC recommends that harmonic levels be limited to acceptable levels. Transient voltage surge suppressors, or TVSSs, are devices that protect electrical equipment from voltage surges or spikes. Voltage surges can be caused by lightning strikes, power grid switching, or other electrical disturbances. TVSSs are designed to divert the surge current to ground, protecting sensitive electronic equipment from damage. The NEC recommends the use of TVSSs in certain applications. Power quality refers to the quality of the electrical power that is supplied to a building or facility. Poor power quality can cause a variety of problems such as equipment malfunction, increased energy consumption, and reduced equipment life. Factors that can affect power quality include voltage variations, harmonics, and transients. The NEC does not directly address power quality, but it does provide requirements for equipment that can help to improve power quality, such as surge suppressors and harmonic filters. The NEC is not intended to be a design manual. It is a set of minimum safety standards that are intended to protect people and property from electrical hazards. Electrical design is a complex process that requires a thorough understanding of electrical theory, principles, and practices. It is important to consult with a qualified electrical engineer when designing an electrical system. The authority having jurisdiction, or OJ, is the organization or individual that is responsible for enforcing the NEC and other applicable regulations. The AHJ is typically a local government agency, such as a building department or an electrical inspector's office. It is important to consult with the AHJ to determine the specific requirements for electrical installations in a particular area. The NEC is a living document that is constantly evolving to reflect changes in technology and best practices. It is important to stay up to date with the latest changes in the NEC to ensure compliance and to provide safe and reliable electrical installations. Always consult the latest version of the NEC to assure compliance with the law.